Yeah, we are back again. This nodal analysis or finding the node voltages. So to find node voltages, you must know what a node is. Then consider the fact that many nodes or a node or a short circuit connecting a node leads to one node, or two nodes can form one node if they are connected by a short circuit. Then you also have to have a clue about the KCL or Kirchhoff voltage law. Then you need to know that current is equals to voltage divided by the resistance. So let's start. We have our equation or our circuit over here. We are needed to find the node voltages. Node voltages, this include node 1, which is labeled V1 here. Then V2 over here, level V2, our second node. Our third node is V3. So we are needed to find the voltages at those 3 points, this node over here, this node, and this one. So to find the node voltages, we'll use KCL at each and every node. So let's start with node 1 over here. So if you are to look keenly, though the writings are not clear, quite disturbing, but let's focus on it so that you can get to understand. It is also another way of concentrating, so don't worry, it will help you concentrate much better. So this is V1. At this point, we are told that currents entering is equals to the currents that are going out. Currents entering a node are equal to the currents going out of that node. So it means these 3 amp, as you can see, this is the current that is moving here. We have a current source that is 3 amps. This current source, it is 3 amperes. So we have 3 amps getting in. Then we have I1 and IX going what? Going out. So at node 1, we can say 3 is equals to I1 plus I2, which we have this equation here. That is 3 is equals to I1 plus I2. This KCL, Kirchhoff voltage, Kirchhoff's current law. So doing that, this means that if you are to find the voltage V, that is the current I, using the voltage, we have current is equals to voltage over resistance. So let's see. Then remember, voltage is the potential difference between 2 points. So we have potential difference between point 1, this V1, and V2. What's the potential difference? So you start from where the arrow comes from, or the current is coming from, then minus where the current is going to the second point. So it is V1 minus V2 all over the resistance. The resistance, that is 2, must give you Ix, this current that is going through that. So you can see that is Ix is equals to V1 minus V2 all over V1 minus V2 all over 2. So that is Ix. So where there is Ix, we replace with V1 over here, V1 minus V2 all over 2. Then we have I1, which is going this way. So if you are to follow, you will go like this. You'll go with it this way, it's coming this way, then it ends here, you can see. So as you can see, where it ends, it is at V3. So we have V1 minus V3, because there are 2 points you can measure. If you are to measure the voltage across this element, that is the resistor, the 4 ohm resistor, you'll take this V1 minus V3, because the current is coming from V1 and terminating at or going to V3. So you'll get V1 minus V3 all over 4. That's what we have over here. V1 here, V1 minus V3, this one, then all over 4 this voltage. So it's going that way, that way, that way, that way, as you can see. So to remove the denominators, we multiply the equation by 4, or the LCM of the denominators. So we have to multiply by the LCM of 2 and 4 is 4, so we multiply by 4. So multiplying will get 3v1 minus 2v2 minus v3 is equals to what? 12, because of this one here. So we solve this, multiplied by the LCM, got this equation. So it's 3v1, because this, as you can see, we collected like terms to get these. So that is equation 1. Equation 2, this one we are having here at node 2, let's say at node 2. And remember, when you are doing nodal analysis, you must have a reference node. So our reference node is this node that is grounded, or a grounded node, that is our reference node. If you are not given, take any node, any point, make it your reference node, but take the node that is having many connection on the loop or the circuit. So at node 2, this is our node 2 here. So at node 2 we have this current I2, we have I3, then we have IX. So at node 2 you can see ISX is getting in, then I2 and I3 are getting out. So IX is equals to I2, because IX is getting in and I2 and I3 are getting out. So we have IX is equals to I2 plus I3. This one plus this one makes this one, that one is getting in. So we have this equation here. It is a solve when you solve this one after making, so because we have this these are reference node. So at a reference node the voltage is 0. So to find IX we had already found it because it was over here. So we said it is V1 minus V2 all over what? 2. So we have our V1 minus V2 all over 2. So this was our IX. Then I2 we have it is coming from this point, then going to that point. So I2 will be V2, because the current is coming from this point, then going towards the V3. So it's minus V3 all over 8. That's why we have this one over here. Then we have this I3 is coming down towards the 0 or the reference node. So at that point we have V2 minus 0 all over the 4 ohms that are over here. So having that, we multiply by the LCM. We have our LCM as 8, so we multiply all through by 8. Multiplying all through by 8, we get 4 volts minus 4, because of this 4V1, because 2 goes into 8 4 times, so it is 4V1 minus 4V2, then 881, so it is V2 minus V3 plus 2V2. Then we have this equation here. After you collect like terms, you get negative 4V1 plus 7V2 minus V3, which is equals to 0 at node 3. So where are we? This is node 3 over here. So at node 3, what we have over here, this node 3, we have current I1 getting in, I2 getting in again, then this I2, I1, they are getting in, but this current or this current source, it is a dependent source. So it means that it depends on Ix or the other alternating currents in the circuit. So it is 2Ix. We were given already in the question. So we have 2Ix. So to solve it, we have I2 plus I1 is equals to 2Ix. So we have 2Ix. Ix, we had already found it. It's over here, or we can find it all over. Again, this here or here, as you can see it. So to find that, having that 2Ix, we have Ix. Our Ix is here. Our Ix is here. So we replace it here. So we have 2Ix is equals to 2V1 minus V2 all over 2. So dividing by 2, we get 2, and 2 will cancel. So we have V1 minus V3 or divided by 4 plus V2, that is I1, V2 minus V3, I1. You can see we had our I1 here or yeah, it's here also. So it is V1 minus V3 all over the 4 ohm resistor there. We are getting that's why we are getting this one over here. So this is equals to V1 minus V2 because this is our 2Ix. We divided by 2 and found that the 2's will cancel out. So the 2's being cancelled out, we have our equation as the way it is here. So we multiplied by 8 as the LCM, multiplying it by 8 as the LCM. That's when we have 2V1 minus 2V3 plus V2 minus V3 is equals to 8V1 then minus 8V2. So we have the equations here. Yeah, so after collecting like terms and dividing by 3, you get 2V1 minus 3V2 plus V3. So we have, this is our equation 3. So we get 3 simultaneous equations. These are here, they are here. So we have 3V1 minus 2V2 minus V1 is equals to 12. That was our equation 1, if you can recall. It is here. Then our equation 2, this one. Then our equation 3, this one over here. So having the 3 equations, you can solve using any method, but the best way to find it, use the matrix method and find these variables, that V1, V2, V3. So we have, you can use by the Cramer's rule to solve the matrix. So to follow or to solve it, if you have no clear implication or clear clue about the Cramer's rule, I have solved it this same equation in another video over here. Find it and be at par. So we have Cramer's rule says that V1 is equals to dV1 all over D, that's 48 divided by 10, which is equals to 48. Then V2 is equals to dV2 divided by D, which is equals to 24. Then V3 is equals to negative 2.4 volts. So thank you very much for watching the video. Then follow up to be clarified or to be explained to about the Cramer's rule in another video. It is there, and don't hesitate to hit that like button because I know you've gained something. So then subscribe to continue getting much more information. For those in major universities, let's keep focused, work hard, and be ready to learn. We are able. Thank you and enjoy.